lots of different health and fitness APIs, pretty much all of them who haven't given the handling of timestamps much thought. So this isn't so much a talk, it's going to be more a set of puzzles. So here's our first puzzle. This is a picture. The question is this a sunrise or a sunset? We can see helpfully there's a UTC timestamp in there. Looks like 3:30. That's probably not the local time the picture was taken. Maybe there's some other hints. So who thinks this is a sunrise? Anyone? You don't trust me to get up early enough to take a picture of a sunrise? Who thinks it's a sunset? And who thinks it could be either? So if you thought it was a sunset, what's your reasoning here? Any? if you happen to recognize the place, or you can hire a detective and do some detective work and figure out, you may be able to infer. But there's also other potential hints, like in the late in the evening. That tends to be more like pollution in the air. You'll have in your population centers, you'll have redder skies, but doesn't look like this is taken near a major population center, so all bets are off here. So how about if we add in the coordinates? Now we know where this picture was taken. So how easy is it to figure out the local time, combining the UTC time and geographical coordinates? So there's a bunch of methods you could use. Like a really cheap approach would be to go search the internet for a database of mapping cities to time zones and just looking like what's the nearest city. I guess I don't need to explain that it's a rough guess. It's often going to be completely wrong, especially people who live near time zone boundaries. Maybe good enough in some cases, but usually probably not. Another more sophisticated approach, there's you can get this geodatabase, it's a public domain thing down called TC World, and it's going to increase the footprint of your application considerably. You can figure out then how to you get the exact shape of each time zone. You can try to figure out which time zone your coordinates are located in. So that should be always correct, right? Does anyone see any problems there? So one thing here is this database, it will only reflect the current extent of each time zone. And due to politics and general irrational human behavior, these boundaries change. I just read something last month. Certain areas in eastern Ukraine decided to join the time zone Moscow is in. So that can mess up your calculations. Moscow, incidentally, they decided to abolish daylight savings time also this year. So there's a website you could find. I think it's like daylight. It's time zone news. You can see what's going on. It's quite entertaining. So it may work for some applications approach, but it's a lot of tedious work, and you still aren't guaranteed to have correct results. Perhaps the most lazy approach is to use Google Maps as a simpler REST API. You pass in your coordinates and a timestamp. I will do some. I'm not actually sure it takes into account the history of different time zones. And the other issue is they have quotas. So if you have a large database with millions of pictures, to go and figure out the local time. That's probably going to could be an issue. So generally speaking, you're probably best off, if possible, storing the time zone offset when in the case if you have an application that's taking pictures, the local time. So why not just store it so you don't have to jump through all those hoops later to try to fill in the missing data. So one of the more popular libraries for dealing with timestamps in Java is called Joda. How many people here have used Joda? So that's, I guess the rest are still happily using Java util date and calendar. So let's create this, in this example here, we create the timestamp, we put the time zone offset, we create the date time, and then we get the hour of day should be 8 o'clock, right? So if it's 8 o'clock, this test will pass. So who thinks this test will in fact pass? I can see you sense a trap. Who thinks this test will fail? Who thinks it will throw an exception when you try to run it? Yeah, these sounds like a safe choice always. So who thinks it might depend? It could be any of the above, or several of the above. And in fact, that's probably the #1 gotcha with Joda date time. Anything you create a new date time object using the constructor, it's going to properly parse that timestamp, so then it's going to convert it into local time. So if I ran this code here, it would actually work. If I ran it on the East Coast, I would get something else for hour of day. So how do we do this properly? One way, if you have the offset stored separately, you can create a date time zone and pass that as a second argument to the constructor. There's actually another small gotcha here. Just found that in some API I was using last week. Time zone offsets can be fractional. So this another, like we're in a, this will work for us, but there's some like small obscure countries like India that have a fractional time zone, and if you assume in your application you're storing your time zone offsets as separate integers, that's they have like 3.5 hours, minus 3.5 hours. So,
Eric?
Yep.
So, does Joda explicitly assume that if you don't put the Z on there, that it is a Zulu?
So in this case, yeah, you could, it doesn't, so if you're using, putting a Z would be the same as just putting like plus or minus 0, 0.
Right, but that next one didn't have any.
So this here, I haven't tried what happens if you specify an offset and you also, oh yeah, of course, what will happen, it will parse, and then it will convert to the time zone you specified.
So but is it assuming, is it going to parse that and assume it's Zulu going into it? Or is it going to assume it's local?
So when it's, that's the same issue as here. Well, okay, so when it's going to assume it's local time, so the local time zone.
So that doesn't mean that this is going to pass. If the T20:30 is assumed to be local time, and then you say that my offset is actually -7, it will apply the -7 to the local time, and it would depend upon what locale you're in to generate the actual Zulu time to do the -7 off of.
Well, whatever it's using, I just ran the actual code and it passed, so.
You're in time zone.
You are in time zone.
You have a flight and you go.
So in any case, I never really use this variant, because typically when I have a timestamp, I have the whole thing stored in a string. So I'll use this variant here, where basically you use datetime parse, and you have to specify a formatter that says explicitly use the offset that's in the string. Don't convert it afterwards. So that's the typical way you're going to do it. Now, if we're using the new Java 8 time library, they do that by default. So I think that kind of makes sense. Okay, next puzzle. Let's say I go to sleep at 8 o'clock and I sleep for 9 hours. What time did I get up? Let's look at this using Joda time again. So we create the properly. We create the datetime object. Joda has this duration class, which is just basically a wrapper around number of milliseconds. So we add the 9 hours, and so we add this duration to the timestamp. And so now the thing here, the naive approach would be to think, okay, it's 8 o'clock, we add 9 hours, so that would be 5 o'clock in the morning, right? However, we remember that's in March around that time we switched to daylight savings time, and we skipped ahead 1 hour. It wouldn't be 5, it should be 6, right? So at 6, this test will pass. So who thinks this test will actually pass? You don't agree with my logic here? Who thinks it will fail consistently? Anyone think it will blow up? Or anyone go for the safe, it depends option? So this will actually fail, and the issue here is we create this date time zone that has a offset, but just from a time zone offset, that's not enough to know, like, are we going to go into daylight savings time or not? Because there's several areas that will have around this time of year, they'll have a minus 8 hours time zone offset. And some of them may move to daylight savings time on that day. Others may move on another day, and others may not have any daylight savings time at all. So go to daytime. If you do any math with a daytime that has an offset, it just does the same thing and assumes you're going to stay with the same offset. So the proper way to handle this would be, instead of creating a date time zone object with the offset, we create it with the proper time zone name. Also note that, the time zone ID, not to be confused with the time zone name. There's also time zone names like Pacific Daylight Savings Time. That's a time zone name. They're a bit more messy and less standardized. But here our official time zone ID is America/Los Angeles. So if we do it this way, we'll know that, okay, this time zone, it can also take into account changes that were done over time. I think it changed not too long ago. They changed the dates when we switched, so it has this database. It will handle that perfectly fine.
So do they keep a table back in time? Do you know this?
Yeah.
It's kind of painful. And you don't know too many. I mean, you might even not know next year.
Yeah, that's why because you need to constantly be notice for doing an automatic updating system, but constantly be those time zone database updates. That's precisely those people are constantly deciding to change, like when they go into daylight savings time, or deciding like Russia recently they don't like daylight savings time after all, and so if you try to look into the structure of how they store the thing, that gets it's a bit complicated.
So is there only one ID for each time zone, or is America Los Angeles goes the entire slice? Or is that just in the US?
That's the well, there's other slices that it helps with the fact that, let's say it's restricted to the US, because Mexico may have different rules for changing daylight savings time.
Maybe the same offset, but
yeah, exactly. That's like I said before, when we have like a minus 8 hour offset, that could happen to be in any of several time zone IDs. So, I gave it away. So there's, if you dig around in Jodi, you'll see there's also a period class, which seems to be kind of redundant with duration, right? So assuming it's redundant, if I take this timestamp, add a duration of 1 day, I should get the exact same time as if I had a period of 1 day. And turns out that's not true. So anyone want to explain the difference between a period and a duration? So the duration, as I mentioned, is just a wrapper around a number of milliseconds. So if there happens to be like a daylight savings time change with error, you add a full day, you're going to go from 3 o'clock. 1 full day is going to be like 2 o'clock or 4 o'clock. Whereas the period actually keeps track, it understands like 1 full day, 1 full hour. So if you're adding 1 full day, it's going to be 3 o'clock the next day, no matter what. So that's the distinction between duration and period. And the Java 8 time has the exact same distinction. Also note they have an interesting, if you want to actually put your time zone ID into your date string, they have a syntax for that. It's kind of awkward, but
One question. Doesn't this then mean that your calculation should be all done in the Zulu time and only converted at the end or at the beginning? Go from your time to Zulu and then always do everything there? And then you don't have any of these complications.
well, if you're just interested in the number of like elapsed milliseconds,
Like
then
you're gonna add a day or.
it doesn't, but if you actually need to consider that like what's you add 1 full day and you want to know what's the local time, you definitely need to know what the time zone is. Otherwise you don't know what to, but if you just work with milliseconds, you wouldn't know that. So like with the duration, yes, we're going to add a fixed number of milliseconds, but with period, depending on the current time zone and the date, we may actually be adding more or less milliseconds.
But what if you take your time, and let's say 2 milliseconds before the change of the date, that daylight savings time, right? You take your time and you do your calculation in the Zulu time, and then you convert it back to your time. So like if you want to find out the periods and all that stuff, it's always on the Zulu time.
Yeah, I don't think that's going to, it has to know that how much to add.
So then
Right.
that's the
Right.
difference
Add the
comes in the
difference.
conversion to and from Zulu time, right? So it's -7 when you're converting to Zulu time, and it's +8 when you convert back.
Yeah, but it should know that, right? Because if you bring the time zone at the end, at the beginning and at the end, then you're safe.
Well, the point is here, you're going to add a different amount of milliseconds. How do you know how many milliseconds you're going to add? Right? So let's move on, we can talk more afterwards.
What if my app is supposed to wake you up at 8 a.m. every morning? Can't do that in Zulu time.
What if you're comparing yourself to an atomic clock and you're moving the wrong way around the planet? You reincarnate the Morrison and Marley experiment.
Well,
Velocity
that's with so okay, if you want to talk about very precise measurements, so let's go there. So here I'm going to see if let's say have an app that's going to time, can I beat the 100-meter world record in running? So basically, I'm going to take the timestamp when I start running, and then I'm going to run. There's not enough space in here to actually run 100 meters, so just imagine. Then we see when I stop, we get can calculate the duration object. And if this duration, the measured duration is actually shorter than under 9.5 seconds, the test will fail. The test fails, it means I just bet the world record. So how confident are you that I can beat the world record? You think no? Who thinks no way I can beat the world record?
Let's see how fast you can go.
Who thinks it's conceivable that I would beat the world record according to this code? And who thinks I will always beat the world record? It's a piece of cake.
This duration required. Yeah. But for a
Oh, it's
duration,
basically daytime.
Yeah, creating a new daytime. I think in turn just does like system current time millis.
yeah, okay.
So this is actually the same, even if you're just using the more old-fashioned approach. You weren't using joded daytime, or you're just doing like long T0 equal system current time millis. The example will be pretty much identical. But as we're going to hear in one of the next talks, you should always wrap your objects in meaningful classes. So this will usually, I mean, it's once in a while I'll actually beat the world record. So how is that possible? Here's the correct code. So what could happen is that between the time we get the check the wall clock to see when we restart them in the weekend, there could be the system might decide to update the clock, right? And that could just push me over the world record. So that's why I introduced this system nanotime method. So this will, it's not to be more precise, because in most systems they're not really that, they're not precise enough, let's say, to measure like effects of special relativity or anything. First, this will return some like almost undefined number actually, but they guarantee that this number is going to keep on increasing. It's not affected by like change synchronization of your system clock. So if you need to time anything, you're supposed to use system nanotime, not system current time millis. It's also another good point is if you care about timing, you can't just store like a begin and an end timestamp. That may be useful if you're capturing like when did I go to bed, when did I get up. You don't care if there's like a few extra millis or a few seconds in there. But if you need a precise measurement, you'll also need to store explicitly how many milliseconds or nanoseconds elapsed.
What I read though, doesn't the clock guarantee it never goes back? So like if they are going to move the clock back, they actually just slow down the rate of the updates to sort of catch up. Like there's a trick, because they know that this will just break the whole world. Like if system current milliseconds sometimes return a negative elapsed time, like the whole world just shuts down, right? So it never, I think they don't actually do that.
I guess the alternative would probably more likely
do a series of updates.
But like if you're running some benchmark, it will definitely mess up your numbers.
That's right. That's right. It's still, you could be on, but
Yeah, they'll skip a second, and they drop a second, and so they don't update it that second, so that's how it goes back. So it looks like you ran a second faster. That's how you do the
well,
record.
there's another thing with this notion of leap seconds. If you're looking at wall clock time, you have to be careful. But that wouldn't affect like if you're just looking at the long time stamp. It's a local time problem. So you can suddenly have seconds vanish or magically appear. So one final example, as is fashionable these days, we're counting how many steps. So on November 2nd, I walked 6,000 steps. And I want to calculate how many steps did I walk on average per hour. So now being smart and all, I know I can't just divide by 24, because not all days have exactly 24 hours. So I'll take this Joda as a convenient, as a local date class. I can represent a local date, so you don't need to construct this, create this awkward calendar and try to set all kind of fields you're not using to null and hope there's no shift in time zone and messes up everything. So we have an explicit local date. There's a method to convert that to an interval, which is basically just a range of start daytime and end daytime. This class actually doesn't exist in Java 8 time, because they figured it's not really necessary, but I find it useful. So we get the interval, so from midnight to midnight. We check how many hours do we have in there. We divide by the number of hours, which in this case, that's November 2nd. Once again, by sheer coincidence, that's just one of the days where we switch, that's the one we switch back to standard time. So there will be 25 hours. There should be 25 hours in that day, right? So So 6,000 divided by 25 should be 240, right? So who thinks this test will pass? We'll get 240. No one? Who thinks it will fail? Who thinks it will blow up? And who goes for D? So why do you think it would fail?
Standard.
Standard hours,
You did
24,
duration,
so
You didn't test for daylight savings.
No, well, it's we have to have the using the proper daytime zone and
Because you use duration, that just uses milliseconds instead of using the period.
nope, it's it passes. Just to get you confused. Okay, so for your convenience, I summarized all the things you should take into consideration when looking at representing timestamps. The main thing is to be aware that there's more to like stuffing everything into a Java util date or a simple long integer. This isn't a puzzle. I'm just curious. Does anyone feel like when you say start, you should pair it up with stop and begin with end, or the other way around, or does it matter? Who would pair up start with stop and begin with end? I see people like doing all kind of different random variations. Just curious. Okay, I think if you have any questions, we can talk afterwards. Thank you.
It's just, now you're confident. Java 8 times, that's fine. Okay. Time for something slightly different. Okay. Super strong typing. I'll tell you what that means in a minute. But, okay, so Pearson, mentioned already, game company, doesn't matter to this talk, so anyway, that's who I am, in case you're wondering what this is all about. Anyway, so I'm going to suggest a coding practice. So if it's a way to write code, some of the properties you'd like to see about a coding practice, some of the things I like to see in a coding practice. It needs to be really simple. Anything that's really complicated people aren't going to do, it's just anything beyond trivially straightforward is just too difficult to adopt. Very good at a coding thing that you're trying to introduce is something you can adopt incrementally. It's not going to be you're going to just rewrite your entire code base, so if you have something you want to do, you better be able to bring it in step by step. Ideally, if it's a practice, it should be self-enforcing. Hate the systems that people come up with where it's based on conventions or things that it's stored knowledge that's meant to live in the company, and you have to sort of share information around, and don't forget to learn how to do this, and oh, we know it, we always do it this way because that's the way we do it. And that stuff's very hard to keep consistent over time. Code changes, things get out of shape. It's not a good rule. So try to avoid that. And if it's a coding thing, it ought to be the resulting code. It better be significantly better. A lot of stuff. We spend a lot of time worrying about things that don't really make a huge difference. And where do you put your curly braces? I don't really care where you put your curly braces. It doesn't make a huge difference in your code base. Maybe you think it does, but I don't think it makes a huge difference. So it should be something that produces significantly better code. So I'm going to hopefully pitch you an idea that I think meets these criteria. All right, so let's look at a problem. It's a little hard to read, a little small, but okay. So so imagine we're writing a e-commerce site, and it's going to have stuff that you're buying. There's orders, there's users, there's items, there's number of items we're buying, right? Counts, there's prices, maybe there's tax included or not in this order that we're putting together. It's going to be our representation. So this is a pretty simple class. You've probably written 100 classes that look just like this. In your professional career, you've maybe written 1,000 classes that look like this. So what's wrong with this class, right? So one of the questions is, what is not great about this class? Something fundamentally not very great about this class, and if you read the abstract, what I'm talking about is at least one good hint. What's a bad thing about this class? So what's a bad thing about this class?
Too many primitives.
Too many, sorry?
Primitives?
Too many primitives? Sure. Well, too many parameters coming into the constructor that are all very similar. I'm going to get, it's all right, George. We'll get more chances to rag on this. I'm going to rag on this class a bit, so don't worry. Any chances to rag on this class. It's not a terrible class, but it's, I think there's ways we could write it better. So at least to start with, we're going to say this is not great, right? We see this problem all the time. It came up. So people talked about it earlier. So we've got problems that show up where you pass in a bunch of ints, right? So you pass in 3 ints in a row. you should know that this can end badly, right? Let's focus in on that a little bit more closely. So we're going to have a user, we've got an item, what happens when we call it. So these are 3 different ways to build this guy. Every single one of them compiles and runs just fine, but 2 of them are wrong. So which one's wrong? You're going to stare, you're looking, you're comparing, just a minute, it's the correct one's the middle one, right? Not super obvious, and of course this is the classic sort of mistake. We all know this kind of thing happens all the time. You call an API, you get the parameters back to front. Not great. But we all know there's a solution to this problem. This is a solved problem. There's builder pattern. I don't know what a builder pattern is, but here's a builder. So we're going to build an order builder, right? This will definitely improve the situation. It's even better.
Did you know that C# actually has named parameters?
Named parameters. Okay, so that'd be another way to solve it. Okay, well that's great. So if you're running with C#, your life will be so much better. But C#, you're bound to Java. You don't have named parameters. Doesn't matter. I'm not going to suggest it's already the best answer. This is certainly a good answer. You can write a builder, right? So I think most people have seen a builder, right? The idea is you have a series of, you have a separate class, right? This order builder guy whose job it is. Ultimately, the key is, right, you have this build method that actually constructs my order. And so now you've got named parameters to pass in. So things are named. So when we come down to this, I can put them all on one line. Don't make break this up a little bit, but you get the idea, right? So you use an order builder. Now my user ID, my item's my item. I got my count. So at least it's clearer what I'm passing in. Hopefully my error rate at least reduces with the build pattern. So this is great because not only have I fixed the problem, which is plus 1 point for fixing the problem, but it's plus 10 points I use a design pattern, right? So I'm really cool. So this is a great solution, right? All my friends are really impressed. It's like, wow, I did a great job here. So, okay, it's not bad. I mean, it's totally normal. We all write this sort of code. It's totally fine. But there's maybe there's a better way to do it. Oh, there's another problem. So we also had this in our class, right? It takes double total price. Like there goes total price. So the problem is, what the hell is total price? So let's imagine we've got our item coming here, my user, my cents per item is 99 cents an item, I've got 10 items. What do I pass in? Well, I can pass in this guy, right? Count times cents, or count times cents divided by 100. Like, what am I meant to be passing? Is this dollars? Is this cents? What's the actual units that I'm meant to be passing in here? I don't know. So could we improve that? Well, we could go back and change our order builder. This will certainly improve matters. We can say it's dollars. Right? You should be sending in dollars. Don't send me cents, send me dollars. So I'm going to call it dollars, right? And so now, at least that's better. It's a little clearer. Dollars should be 50, so I'm meant to be passing in dollars. If I'm calling that dollars method, I now have at least a hint as to what I was meant to be passing in there. Okay, so is there a better solution? Well, obviously, I'm suggesting there might be. Yes. So I'm going to propose a different approach, another way to solve this family of problems. In fact, I'd say these problems that I'm focusing on here, I'm just giving you a nice simple issue to get your teeth around. These are all pretty minor, but I think the alternative solution that I put out here helps address actually much bigger family of problems than just this, and gives you much bigger bang for your buck. Okay, so what's the alternative? So imagine we have an even bigger problem. So we've gone ahead, we've built out this whole e-commerce system, right? We've been working with this for 6 months, 9 months, 2 years, who knows, right? We've built this wonderful system. Let's say it's 100,000 lines of code. It's a great system. It's wonderful e-commerce. And one day, our business people come to us and say, we just have a little change. There's just this little thing we need to change. You know those item IDs you got in the system? They're no good. We need to turn them into UPCs, and that means they have to be strings. So if you just go in and fix that, please. And whilst you're in there, we decided it's not okay to store currency values in a double. We need to store them all in big decimals. So whilst you're in fixing the item IDs, can you just fix the list of big decimals, right, at the same time? So conceptually, these are small changes, right? This is not a big request. Because it should be a small change, because look, I mean, I didn't put them up in one sentence. It's easily described change. But it may not be an easily described change in your code, right? So let's go back and look at our classes. These are our 2 classes we've had so far. Order builder, our little friends. So we wanted to change the item ID. Well, how many different places is the item ID appearing? So there's 5 references in just these 2 classes to these int types that we're meant to go off and change, right? They're all wrong. What about our pricing? Well, it's 5 of those too. It's great. We've got doubles, all the prices in every step. And that's just 2 classes, right? If you're doing this for real, you've probably got this in hundreds of classes. You've probably got this all over your code base. So, could be a ton of them. So what's the root problem? So I'm going to suggest the root problem is too much reliance on these primitive types. We do this all the time. We write code with primitives everywhere. We don't really realize what that's actually creating. So int, string, double, we use them a lot, and we probably shouldn't be using them as often as we do. At least that's what I'm going to suggest to you. The result is the code is tightly coupled, right? The code is actually tightly coupled, but it's sort of invisible where the coupling is, right? If we go back to that slide, the whole point of this is there is this kind of loose coupling, right? The type for that value is rooted through all your code. It's not obvious. You don't normally think of coupling in this kind of dimension. It's in the types being used across your whole code base. You'll often see this. So it's, well, hang on, let's hold on to the questions so we get a little further in.
And I know the answer.
Sorry?
Build an enum.
Build an enum. Well, we'll
Yes.
talk about that. Build
Doubles
something.
and
Right.
ints.
It's not just an enum, but we'll talk about that. Right. Build something else. Okay, so let's look at that a little more closely. So these ints in this particular case, right, like user ID and item ID, so they're not really, I would suggest, normal ints, right? They're basically identifiers, right? They're actually just identifying something else that's in your system. And so we shouldn't be treating them just like regular ints, like an index or a counter or something else, right? They have different properties. So what properties do they have? What are the real properties of int? Well, sure, they represent a number, but they also have these strange properties, right? Ints are really well designed to do mathematical operations. That's probably not something you really want to encourage, right? Do you really want to be able to do user ID times 3 plus 1? Right? That's not a common thing that you really want to make easy to do, but that's what you're saying, right? When you say this type is an int, you're kind of saying what we're good at doing with this is mathematical operations. Well, you definitely don't want to do that, right? That's almost never going to be correct. But you can write that code pretty easily in many systems and accidentally be passing user IDs and it's summing their user IDs or doing all kinds of crazy stuff. Not a great idea. Same issues come up. It's not picking on ints. It's strings got some of the same issues. All right. So what's the alternative solution? So we can wrap it in another class. So this is the incredibly complex suggestion, right? You just wrap it into a little class. So here's our item ID, and it's a super complex class. Look at that guy. It's got 2 methods and one value. So public class item ID, final value, which is actually the item ID inside, a constructor, and we call these things v methods, value methods, just a way to get the value back out again if you really want to get the int back out. And make them simple names. That's that amazing class. Get you a lot of bang for your buck. There's not very much to it. So one key point of this, these guys had better be immutable. You start trying to do this, do not make the mistake of making this a mutable class, right? If you make one of these little wrapper guys, it had better not be mutable. That's because you're trying to get the same behavior as primitives, right? You might think, well, primitives are not mutable, right? I can take a variable and I can assign 10 to it, and I can assign 20 to it. It's like I mutated it. But no, that's not the mutation we're talking about, right? If I give you the value 10, I can't go in later and change all the 10s in the system into 15s, right? I give you a 10, it's always a 10. What I gave you is the same value. So these are better to be immutable, right? Primitive values can't be changed. And obviously they can't be changed. You can't go and change a primitive value. So it better be if I have an item ID that's 700, I create a little class that represents this, better be I can't later on change that value. If you do that, you'll be in a world of pain and suffering. So please don't do that. Okay. What about currency? Do the same trick. Right, well, what do we have? A little client class, again, incredibly simple. You can see there's a certain pattern developing here, right? US dollars. It's like, okay, this guy stores some value. So now we're doing it with doubles. Represents value in dollars. Okay, so let's go back to our original class and think, well, what does this class turn into if we adopted this kind of pattern? Well, it's really similar looking. It's just it's got a whole bunch of these types not showing up. Right, this guy's a user ID, that's the US dollars, user IDs, item IDs. Right, we can see the nature of what we changed. So let's go back and look at the original problem that we had. Right, what happens now? Right, so we do the same trick. We get a user ID, we get an item ID, and we try and call our order constructor, but we screw up. We get the parameters out of order. But what happens? Well, now 2 versions of that don't compile anymore. Right, because you can't pass a user ID to an item ID. You can't pass these values to the wrong types. Your compiler just steps in and says, hey, this is no good. You can't write this code. This is completely unreasonable. What about when you try to do the dollars, right? Same trick. Build a US dollars object now. We're going to build this thing up and pass it in. So maybe we try to pass in an order object and we just take a cents. We've got this cents stored as double. We try and multiply by value and pass that in. Again, just won't compile, right? It's like that's not going to work. You can pass in this dollars object. Now you can still screw this up You can still go wrong, right? What you can still do is you could build this incorrectly, right? You can still take a count multiplied by the cents price and build that object. So you can still make a mistake. It's not stopping you being able to make any mistakes. But the mistakes
Builders
become...
for your strong types.
Yeah, no, the builder doesn't fix that either, right? You can still always screw it up. But what it changes is the problems become just when you create the typed objects, right? You have to be very careful at the time you get it wrapped up into one of these safe guys. So at the moment you construct it, you can screw that up. But once you've done that, if you get the objects constructed correctly, you put an actual user ID into a user ID object, you put an item ID into it, you put a US dollars amount, a dollars amount into your US dollars, it's fine. After that point, you're not going to screw this up. You're passing around the object, and it's kind of the read versus write pattern, right? Most of the time, if you look at your code, generally, you probably aren't just creating a ton of these objects, right? Most of the time, you look at sort of software that will almost right, you get one of these things out of the database, or you get it from a request, you build an object, and then you may pass it through a bunch of methods. You may pass it around your code base a lot. That's a normal pattern that you'll see in code. There's a lot of values passing through it, but not a lot of values actually getting built. So you have to be very careful when you build them. But then you can pass it around, you've got all this wonderful typesetting. You've suddenly got yourself a much more powerful system. So let's go back to our changes in requirements, right? Item IDs, we can turn them into UPCs. Currencies all have to be stored in big decimal. Let's say you also user IDs, we're going to turn them all into longs. So every single one of them has to start 0, 1, 0, because that's just the way user IDs are going to be in our system now. So what's the problem now? Okay, well it actually becomes pretty simple. We go back and change these wrapper types and fix any compilation errors that show up. There may be a few, but there won't be a ton. So it can turn problems that used to take weeks of work into problems that just take hours, right? And this kind of stuff shows up, at least, I don't know, where I work, this kind of stuff shows up a bunch, and so it's really helpful. So let's go through an example, right? So we're going to turn this item ID into a string, instead of an int. So we go into our item ID object, the thing that actually represents an item ID, and now we have a place to make a central change, right? It's like this should be a string. So what breaks? Well, the places it'll break would be where you construct it, right? You built one of these, somewhere or other you're building this, but it's great because it fails with the compilation error. So you know right where in your code where you built all of these guys, and you get to go fix it and say probably there aren't many of these. It's pretty weird if you haven't been built in all over the code. That's strange. Or any place that you sucked the value out and decided to actually work with the raw value. For some reason you have to do that, which there can be cases. But again, it's nice, you get a straight up compilation error. You get many compilation errors, you go through, you fix the compilation errors, boom, the whole system should be working. So it's a lot easier than doing the sort of hunt the code base problem, where you try and wander around the whole code base and figure out where is it that all these references are, and find the one and change them. Okay, well this is great, but how do I actually work with the printer? Say I need to, what's the method for that? Well, that's easy enough, right? All you do is, if you want to, you can get this value back, right? They have this accessor. So for instance, say we want to compute the tax, and I don't want to work with these wrapper objects all the time, I don't want to work with these US dollar objects. It's fine, you can put them into a double, walk through the list, we're pulling out the prices here, right? These are these US dollars safe objects, and then you get the value, and you multiply by the tax rate. If you want to write this code, it's very easy to write this code. Part of the reason why we just use these V methods, right? So it doesn't make the method really complicated. You could call this get value, and anytime you want to suck this out, you know this is really sort of expanded code. It's just confusing. You don't need that. The point is you're trying to get the price, right? That's really what you're thinking about. There's only ever one method, so might as well just use that. So this code is fine. This is not terrible code in this kind of system. The key is stuff coming in and out better be type safety. So as you cross method boundaries, you really care about the type safety. You may also care about it inside a method, that may be fine, but it's not the end of the world if you want to just break it down and operate on the objects again. It makes the code simple enough. What about a whole lot of extra classes, right? So it may come across looking at this, it's like, well, this is great. All I have to do is take every single class I ever wrote in my life and return every primitive into a subtype. Well, now you just maybe write thousands of extra classes. No, it's not really the case. I mean, this is bad because you're looking at a very simple example, right? When I'm showing you an example with just a couple of classes, it looks like, well, you just added like 50% more work. But that's not really what's going to happen in a real code base. You only have to convert the parts that are significant, right? A few major types get reused all over your code base. Normal code base, right? The user ID is an e-commerce system, an item ID, email addresses, US dollars, a few crucial types you're going to see a lot of places in the code. So you get those few types converted, and everything should be fine, right? For our case, today we have about 250,000 lines of Java code on the back end, and we use about 40 of these types. And so probably we use about 20. So it's not a vast explosion of types where everything just needs to get much more complicated. And each type you add here, remember, is incredibly trivial to write. It takes, 15 minutes, 10 minutes to write these new types. They're not complicated. Okay, so let's go back to that coding practice stuff that I pitched at the start. So it needs to be simple to understand and implement. Well, this is pretty darn simple, right? You look at these classes, and each one is incredibly trivial. It's just one immutable value. That's all these classes ever are. I've never yet had to actually explain the system. Anyone's come in with the code, they're like, oh, okay, I see what's going on here, right? It's not a weird, complex kind of thing to pick up on. You need to be able to adopt it incrementally. This has been really important and a nice thing. So for instance, on a user ID class, in practice, you can't just convert all your code over to using this. So what you do is write some chunk of methods, some little section, and start doing it in this sort of type-safe way. And when you cross in and out of the boundaries, you just convert in and out as an int, right? Whatever the representation is you're using, string to user ID, whatever the point is, across the boundaries. So you start writing this code that can wrap up the object and pass it around type-safe as a chunk of the code and converts it back when it needs to. So it's fine. You can just easily do it incrementally. And indeed, we've been doing it incrementally over years because we didn't have this idea at the start. So it's been something we've been adopting, and it's an ongoing process, but more and more. It's getting easier. The whole idea of self-enforcing. It's really nice, actually, because this rule, if you write some of the code, make it type-safe, it's easier to write the type-safe code than it is to write the untype-safe code, right? Like this is the untype-safe code, right? Somehow I've still got code that's using an int for the user ID, so when I want to call to my order system, which is type-safe, I have to wrap it up, and then when I get it back out, I have to unwrap it. So I have to write more code. This is a great rule, right, for any development practice. If it's less work to just do it the right type-safe way, I'm going to get slowly persuaded to write it the type-safe way, right? Life is actually easier, so it sort of impacts the system in a good way. It becomes easier to write the type-safe stuff, so you just start writing the type-safe stuff. Why not? Okay, so does it produce significantly better code? Well, so I point out a few things that comes better, but there's a lot more advantages. I'd say it produces much better code. All right, so we covered this one, right? Harder to pass the wrong values. Now, I'd say that's definitely a problem, but I don't think it's a huge problem. It's just a problem. But, okay, it makes that problem basically go away. You get compilation errors, so that's definitely a win. It's just harder to screw around with identifiers, things that are meant to represent properties. It's just harder to write the code that mucks with them. Like there might be some place you want to add one to a user ID, but it's not a common pattern, right? So at least you're going to have to work harder to do that now. Right, in your current code today, generally speaking, just go user ID plus plus, code runs fine. It's like, well, did you really want that? You can still do it if you really want to, but it ought to be a little more awkward. So this sort of stuff just makes it a little awkward. And of course, mixing up the types, assigning a user ID to an item ID, kind of stuff that we all screw up every once in a while. Again, it's type safe, right? You can't do it. You just don't do it. Your compiler's just helping you hold your hand on this stuff. Error checking. This is a really nice side effect of this, right? So say, for instance, you want to make sure that all user IDs are positive in the system. Well, now that's trivial, right? You just write in the constructor a little test, right? And you just check every user ID that ever gets built in your entire system, right? Inside that constructor, you just say, user ID is less than 0, throw an exception, right? Done, right? You didn't have to go off and write all the different places you build a user ID and write a little verification code in all the different points that might go into the system, and then you forgot the one that came out of the NoSQL database that you just hooked up last week. And somehow you get modeled up, and that one's negative, and the whole system starts to blow up, right? This is a nice feature. We did this for the percentages, right? Values that have to be, say, between 0 and 100. They can present real challenges in a practical system, right? Because these are represented for us, they'd be doubles. But one of the problems you get with that kind of thing is if you sum up a whole bunch of values, right? You should get a value that sums to no more than 100. But we know you can get rounding problems. So you can get all kinds of really nasty problems in a real system where it totals to 100.000000001, right? And that may cause some nasty exception in your system. And it's very rare and very unlikely to happen, but under certain conditions, you can get that. So it becomes easy to write the class in such a way that it allows for that, right? Our percentage class checks for that because it's in the constructor. It says if I have this very small delta over 100, I'm just going to flatten it down to 100. So that's almost certainly what you meant. But if you have something that's 100.1, your code's broken, and you shouldn't be calling this guy, right? This thing's only meant to be between 0 and 100. Same thing with dollars. It's nice you can make sure that all the dollars in the system are positive. In the case where you want them to be positive, you might allow an explicit flag unless you build one that's negative, because there's cases where you want things to be negative, but most prices in the world aren't negative, so you want to handle that probably as a constructor. So all of this kind of error checking just got a lot easier. And that sort of thing is very hard work otherwise, because you've got to go through a ton of code and add the error checking all around the code base. Suddenly it's just in the constructor for this type, so life's easy. Another nice benefit, finding references to where these types are used became a lot easier, right? So if you want to find all the places where item IDs are constructed or all the places they get used, your compiler, your IDE will tell you this stuff, right? It understands types, it knows where to find all this stuff. So if you want to go search for the references, you can find them all. That's nice. So you just want to see how many different places do we building user IDs? Well, you just ask your IDE. It'll take 5 seconds. If you want to hunt it down otherwise, it's a giant sort of grep search or something in the code base. It's not fun. Okay. Other reasons it's better. This, I think, is probably the single biggest win. It's hard to convey on a sort of quick talk. The code just is vastly clearer, right? If you look at something that starts saying US dollars, compute the cost, pass me a user ID and a list of item IDs, like that's just so much easier for my brain to understand what this method does than, you know, double compute cost int user list of ints. And you're like, what is this stuff, right? What is it passing? You spend a lot of time reading the variable names. We get very good at that, right? And trying to interpret what the values really are, because that's the only information you've got, really, is the usernames, the variable names. But if the type systems there to help you, it just gets a lot easier to understand your code. It's a lot easier to see what's really going on. You're not as reliant on people reading the variables correctly. Major refactoring is a lot easier. We talked about that one, right? That's potentially a huge win, right? If you want to change some of these types in your system, that all got a lot easier. Things tend to show up as compilation errors if you screw it up, so that's a big win. And there's a nice benefit. Writing code is actually a lot faster, right, once you do this. That's another nice benefit, right? You've adopted a practice that seems like, well, I have to write these extra classes, I got this type safety stuff, why am I bothering to do this? Well, guess what? All your code got a lot quicker, right? Say, for instance, I write this in my IDE, right? User ID space, my user space equals user.get, right? Then whatever the extension is, tab, right? Something to get what are the possible methods I could be calling here, right? Your IDE is really smart. It knows there's only one thing on this user object which has maybe 75 methods on it, all of which called get something, right? That returns an object of type user ID, right? It's not like all the things are returned in. It's only one thing that returns a user ID. It's the method called get user ID, right? So you just hit tab, whatever it is, and boom, that's the method writes itself for you. So you start finding that life's got a lot easier because you can write out your code quicker, right? This is a really nice benefit. Life is a lot faster to type. You don't get given many choices from, I call it IntelliSense still, because that's what he's called in Microsoft Tools, but whatever you think of that little guy that helps you type your code. IntelliSense. Is it still got IntelliSense? Is that right? Anyway, so upshot is we've been using this for years now. Haven't yet found any reason not to do this. It's also really easy, so you can just go out and try it, right? So you can subversively give this a shot if you want, wherever you're working, and go create like 3 classes like this and say, well, I'm just going to see, you know, I don't know, maybe this will be really horrible. There's really nothing much to it. You write a few trivial classes, you start representing them this way, and say, oh, you get all this freebie stuff.
If you've got a user object, why wouldn't you just pass that around instead of?
You can pass the user object, but still, it's assuming you're passing the user ID as well. I mean, it depends on the code base. You might be passing a user in some places. Maybe you don't use a user ID much, right? Because you don't care. But a lot of code is not going to just pass the entire user object every place. That's sort of another question of is it tightly coupled or not, right? You should be passing just the minimal amount of information rather than passing the entire user object to everybody and have to pull out the user ID. It depends on your theories about what's the right representation. But so there's lots of places where you're going to pass something other than just the bigger classes.
Are we going to look up the user?
Yeah, you'll see that kind of, this kind of code, at least in my experience, you see a lot of code like this, no matter where you are. You certainly don't have the large user object, but it doesn't solve this problem. So, like a TV infomercial, but wait, there's more. So, one of the things, so actually we make it a little more complicated, right? I like to present it as a simple kind of representation. We make it slightly more complicated. We add one more thing to it, which is really an interface. Right, so one of the things that you might have noticed if you spotted that, one of the things you lost along the way is the ability to operate on things that are integer-like in a group, right? So we put a really complicated interface in there, right? It says, gee, this is a data int value, so it has a value that can be converted to an int, right? That's all it's telling you. It doesn't have anything much to do with itself. It's like that. And we actually put in, we prefer to do like a factory method. We have these make methods. That's this guy, right? It's static. Methods. That lets you, if you want to, you can do things like always return from a set. You can have a map behind it, and you're returning actual instances. There's different benefits potentially from being a static constructor, so we do it that way, but that's not a huge difference. You also add equals and hash codes. You can stick these into the map. You know, a few little touch-ups. But the main point is this interface. This interface does have some really nice value, because then you can write general purpose code that operates on anything that's a data in value. So for us, for instance, when we send it to the database, we can just send down these things, and it says, oh, okay, I got one of these data int values getting sent to me. I know I can convert this to an int, so I'm just going to convert it to an int and write it in the database. Right? It's like you can write general purpose code, or you can process a list of data int values. If you want to put comma separated lists together, and you know these are all ints, you can build it that way. Right? There's lots of things you can do where it's operating on a set of things that are int-like. So it's just nice to have that very, very simple interface. Well, it's simple interface. But a little bit more. So just to keep going with the same idea, and another one, I haven't beaten up on the last method on that, the last parameter of that method, so I can beat on that guy too. So remember back at the start, you've probably forgotten already what that false represented. Who remembers? It was where the tax was included, right? So you might have forgotten that along the way, but we have an alternative way to do that too, right? Which is this incredibly complex class, which represents a value like, is the tax included, with these very complex dudes, true and false, right? Like, is it, I think I wrote that wrong, I think I should have brackets around it, that's what you get for coding. Yeah, but the point is, pass it in like this, right? Tax included, K false. It's a lot easier to look at this for the same reasons, right? Than looking at these false methods that we see all over the code, right? Where you just pass in trues and falses, and you're always wondering, well, the third parameter along, now what was that one again? And what is this one set to true, or is it just a false? When is this? You know, just makes your code a lot easier. This is not rocket science to this, but this doesn't even have the v methods or anything, so it's just using the unit to pass the values around. But it gets the same bang for the buck. Of course, you get the type safety again. You know, if you try and pass tax included to something that doesn't take tax, you'll get an error, you get a compilation error. We like compilation errors. That sounds wrong. All right, so this would be the final signature. Take out the variable names, right, for that order class. Going back to the example, pass the user ID, pass the item ID. Would still pass that as an int. The count actually is kind of an int. To me, that's fine. I wouldn't mess with that. That actually is an int. Like it goes up and
You
down.
only want positive values there.
Well, you know, that's fine. But I would check that probably just in the actual value. You could represent a count. We get even more hardcore than we are, but you know, we would allow that one to be in. We just leave it alone. Pass in US dollars, a flag, say the tax included, and okay, look at what we're gonna represent. So, end of the story.
Why do you do K true and K false?
Sorry?
Why is it K true, K false instead of just true false?
Oh, dang, that's because I'm weird. Yeah, I don't like capital letters. Yeah, so this should be, sorry, yeah, that's bad. For this, it should just be all caps true and all caps false, right, to follow the Java standard. We put a little K in front because I just don't like staring at all of caps, for instance.
Well, that's like a C-ism, right?
This is non-standard, sorry.
That's like a C-ism, right? Using
It is, it goes way back, yeah, exactly, exactly. So just ignore that, because that's not standard. Everyone else doesn't do that, so that's fine. We just do K2.
I would put yeah, but no.
So, to be the devil's advocate again.
Do the advocate.
So there's obviously a performance cost with this in Java.
Yeah, essentially,
In theory.
if the cost of making one more local object is relevant to your system performance, then you shouldn't adopt this. But I've never seen a system where that would be even vaguely close to true, right? It's like this, it's very bizarre if that would be an issue, right? We know that constructing local objects, hey, Java performance, you can come to the Wingdings group and learn about Java performance. Constructing local objects costs you basically nothing, right? In Java, if you're just constructing an object, you go throw it away shortly. We all know about generational garment vectors. It doesn't cost you anything. So the only time that would be an issue is you allocated millions of these and you kept them all in memory for some reason, and you're very close to the limits. I mean, it's just not an expensive kind of thing, right? So that shouldn't be a concern. We all know the reason your app runs slow is because you're talking to the database anyway, so it's not going to be, this should not be significant. If this is significant, something weird about your app.
In your problem set, almost all of these are going to be stored on the stack anyway, right? Because you're getting some data from the database, you're processing it, and you're returning an answer, and then you're throwing the whole thing.
Yeah, that's right.
Well, it's heap allocated. But
It'll be on the heap, but I mean, it's going to be for a little while. It won't hang around.
Well, the JVM
If you stick it in a map, you can stick it in a map, but it isn't going to cost you a lot.
It's in the nursery
escape
space.
analysis, right?
I will just say that the performance cost, it pales in comparison to having one of these bugs get into production.
Oh, yeah, I was just going to say that.
Good answer. What a great answer, George.
Yeah. Seriously.
Eric.
So let's say you're doing like your money adding up in a loop or anything.
Yep.
The if what we learned is through the JVM, we should be doing escape analysis, actually not even bothering to basically unwrap your object and say, well, I don't actually need to create those US dollar objects here, I'm just
That's
going to use the doubles
That's
directly.
right. Java is way smarter than you can ever imagine. That's right. So if you need to write a little loop where you're creating these, it doesn't actually have to create them. If it can figure out, it doesn't have to make these objects, it'll just throw them away.
Yeah.
Even faster. But as I say, if this is really where your performance issues are, I mean, it's not hard to see. You can easily work around these performance problems. If you're really writing some tight code, you don't want to allocate 1,000 objects, well, just don't do it, right? Just store them in the primitive and avoid this is fine. Yes.
When you have these objects that, just wrap primitives, how do you make a decision versus calling dot equals or v equals equals?
That's a good point. So that's one of the sad realities of the Java database. Switching over, it's a pain because the equals is wrong in Java, right? It should be that double equals should call the equals method on an object, and it just doesn't. So that's right. That's actually one of the ways you have to watch out. You have to be careful that you don't get caught converting a primitive over and using double equals on an object now when you have an issue. So that's actually one area you have to be a little careful. If you're doing a bunch of quality tests and you convert a bunch of code, you could miss out because that's a good point. That's a potential thing. That's a potential gotcha.
So which do you favor? Sorry.
Oh, I mean, you should use equals once you've converted. You use equals because double equals is wrong. I mean, because it's only going to be correct with double equals. Double equals is identity of the object, right? That's only true if you did the model where you had the static factory and it always returns the same instance. So if you ask me for the user ID for 7,000, I always give you back the same guy, which I can do because I can write a map behind it and I just create them on the fly. But you shouldn't assume that, right? You shouldn't assume that I'm going to do that. So you should call double equals.
You want to use integers for percentages,
Yes.
100.
Right. And so we do some tricks. I mean, that's actually what we use the static ones for, is things like if you do ask for instance, on percentage, right, if you happen to be asking for 0 or 100, which is a very, very likely value you're asking for, then we just give you back a static instance, right? Because there's no need to construct a brand new object, because we can tell those ones are, right, what are you going to initialize your rate to start with? You're going to start with 0, so that kind of thing trick. Yes?
Do you find these types attract additional methods?
No, basically they don't. I mean, there's no real reason to add extra methods. It's part of the reason we mostly do the math outside. Like early on, we started writing things like adds and subtracts and multiplies, and you can get it a little fatter. And that just makes things more complicated. It just seems a lot easier to jump it back out to the double. The reason it gets complicated is because it's not real clear as to whether something is immutable or mutable, right? If you call add, it's very easy to start writing a method that takes the value and calls add 7 to it, and you think you modified the thing. And since it can't be, it's immutable, it actually makes it hard to read the code, and you can write the code wrong, we just started taking all that crap out. So it really, this is all that they ever have. I mean, there might be something where you might add a helper method or something on top of it, perhaps, but basically they all just look like this.
How do you deal with the fact that you just shouldn't be using double for money? And hence, having adds and all that jazz in your US dollar thing at least isolates the math inside of whatever you're cheating.
At least that problem seems tractable, right? If you started writing with double, you're like, that's really bad, at least you have a chance to go back and fix it. Because if you change that to big or whatever you think is a reasonable representation of currency, then you're going to get these compilation errors, right? If I wrote that little loop, remember that little loop I had which did the action that added tax, it won't compile anymore. Because it's going to do double times big decimal, and it's going to be like, what?
No, I'm asking, for currency specifically, it might make sense to actually have the add method in it.
Sure, well, if you decide if you think that makes sense, no, it's your code. You had an add method, but we haven't had to do that. We haven't felt the need for that. It's, it's not, we don't run into that problem, I guess. You don't actually do that much math on it. For our currency, you generally don't do much math on currency, weirdly enough, right? You generally get it for us, you get it and you store it, right? You don't do a lot of math with it. It's not a thing to do a lot of math on it. It's also you do actually English on time.
So you talked about adding exceptions to your constructors.
Yes.
How do you do it? Do you do it as runtime exceptions?
Yes, yeah, because they're a legal argument, right? I mean, you're constructing something with parameters that are not valid, so it's an illegal argument exception in that case, and you appropriately throw it. And it's nice because you get the error immediately that it happens, right? It's like you get the value from wherever you got it, probably from some, right? If you're getting, say, a user ID that's less than 0, you're probably calling, maybe it's the parameter that's being passed in to a REST API or something, you get it off over the wire, and you build the object, boom, it blows up, right? You can't sort of infect the rest of your system by writing that in the database and doing something you really didn't want to do, where it sort of spreads around, so it just works well. And I should stop talking. I'll take a moment.
All right, I'm Peter Dillinger. I'm back from last month. We had a cancellation this time, and so I got to throw in my little short talk to give you. If you weren't here last month, I'm from Coverity. We brought this Synopsys swag because Coverity was acquired by Synopsys. I'm going to talk to you about a bit of Java language stuff that I ran into in doing some of my job work. It has to do with something called stack maps on in the Java bytecode, and how this influences instrumentation for Java. So, little quick introductory information. I have an academic background in program analysis and verification. I've been at Coverity for 5 years. We opened an office here in Seattle about 2 years ago, and I actually made a move to Seattle. I'm kind of the technical lead for Java analysis. There's some other people who sort of overlap with me a bit. Coverity, our marketing people call it development testing. So we make products that help people find problems in their software sooner and find more of the problems and all that kind of thing. We're best known for static analysis, which is analyzing your code without running it. We just kind of, I talked about this last month. We look for patterns of problems and execute your code sort of in an abstract, looking for problems. We find both quality and security problems, where by quality we mean like crashes, logical errors, resource leaks, those sorts of things. And security like cross-site scripting, SQL injection, hard-coded credentials, insufficient cryptography, all sorts of things like that. And we also have a tool that finds problems based on dynamic analysis. So you run your product and it watches while it's running and sees if you come close to having some sort of problem or actually have some problem, and it'll report that. That's actually what I'm going to talk a bit about tonight, something I ran into working on that product. We have other things that help with this, like I said last time, with imperfect bug defenses, it helps to have a variety of different approaches to help you find all those bugs. You can find more information on the web, of course. So, Dynamic Analyzer, this is a product for Java. It finds resource leaks, deadlocks, and race conditions specifically, because these seem to be things that are we can find more effectively perhaps with dynamic analysis than static analysis, or at least find an interesting different set of defects than we can with static analysis. So it works by, you add a Java agent to your Java virtual machine invocation. There's this -Java agent option, and that means, all right, this code gets to mess with the code that gets loaded into this Java virtual machine, so it can monitor what you're doing and all that stuff. We have a new release coming out that has a cool new feature where you can just say cup capture and then your test command, and it will automatically instrument, add this agent option to all your Java virtual machine invocations that happen under there. So you don't have to go and dig through your Ant or Maven scripts and figure out where all the Java virtual machine invocations are. And also Java 8 support. And this was the tricky bit that I'm going to talk about. And in particular, there was this little feature. So this is somebody at Oracle announcing, hey, we're going to deprecate this option that was present in Java 7. When they say deprecate, they mean it's not going to work anymore. And so that caused me a little bit of hair pulling, not too much. So I'm going to talk to you about what that's all about. And before I go further, I have to credit a blog post by Prashant Deva, who really outlined basically everything I want to tell you from here on. But, you know, I ran into this, it caused me some grief, you know, I think, you know, other people should be aware of this. And so I'm, you know, doing my part in sharing that and educating. So the problem was, so the thing Oracle was trying to do was, in theory, there was this problem that bytecode verification is too slow. I think that they were maybe just thinking it could be a little faster, but they thought it was too slow. And so they decided the way to solve this is to embed in the bytecode type information on the stack operands and actually local variables. So if we have more information about the code, the bytecode, we can verify that it's type safe and all that good stuff more quickly when we load it. Just a little bit of history here. You know, this is like the Java 5 days. Java 6, this was apparently an experimental feature to have this extra information embedded by the compiler. Java 7, this was a feature that was on by default. The compiler generates this information. The Java virtual machine expects it to be there. But conveniently, you can pass this option and it doesn't have to be there. So that's convenient, and that got us through the Java 7 days. But in Java 8, there was, you know, they said this option will no longer work. And so there's no workaround. We have to put this information in our bytecode. Yet, it seems odd because the Java virtual machine can run code compiled, you know, from Java 6 or earlier. So it still has to have the old verifier, the old slow verifier in there also. But they have this new faster verifier, and they're forcing you to adhere to these new rules, even though, you know, forever they're going to have to support this old format. So they have to have the old code in there anyway. So like, come on, guys. Anyway, let me tell you more about what the real difficulty is. So here's a little example of some Java bytecode. I have some source code here up at the top. It just takes a Boolean and does a little if. If the Boolean is true, then it returns a new C1. Otherwise, it returns a new C2. And so if you aren't very familiar with Java bytecode, I'll try to explain this to you. So it works with an operand stack. So you know, you're like your HP calculator where you push 1 and you push 2 and then you say plus, and then it pops those 2 off the stack and then pushes 3 on the stack. So here it says, okay, I load 1, that means it's going to load the value that was in the first parameter, push that on the operand stack. Here it says if EQ, that means it's going to pop a value off the stack, and if it's 0, is that right? 0, no, if it's not 0, then it's going to jump to location 14, and I've indicated that with the convenient little arrow that it jumps to, you know, before this instruction starts. Otherwise, if it is 0, then it's just continues to the next instruction, etc. So new here creates a new object of C1, pushes the reference to that on the stack. Dupe will duplicate that reference on the stack. Invoke special, it invokes the constructor on that object. This is a little kind of a weird, strange thing about Java bytecode. Whenever you create an object, it kind of always has this little sequence where it actually creates the object, duplicates the reference to it. So now we have 2 references to it on our stack, and then we're going to use one of those references to call the constructor, and then we're left with 1 reference on our stack. In this case, we go to 21, and it says a return, so we're going to return that reference that was left on the stack. So anyway, we have this little, you know, split, and then we join together for the a return. And what's missing from this is this new stack map requirement. And what this requires is anytime we come back together in the code, if 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 we come back together in the code it requires us to record what is the type of the things on the operand stack, and also what's the types of things in local variables. So what's at issue here is what's on the operand stack. In this case, we're putting a reference to a C1 on the operand stack, and then we go to 21. In this case, we're putting a reference to a C2 on the operand stack, and then we reach here. And the verifier is concerned with, all right, I'm returning this, so and whatever I return has to be a comparator. To make the verifier's job easier, it's requiring me to generate information that says, all right, what is the type that these two come together to that's going to satisfy this verification condition. Now you could imagine that, in this case it's not too hard because I'm immediately using this in a situation where there's some verification condition, but you can imagine it could be a lot more complex, and it passes through other local variables and eventually ends up in some place where it needs to verify a condition. And so yeah, in theory, the verifier could have to iterate through the code, make several passes over the code. I think it could be quadratic in the worst case, maybe. Yeah, some of you might know better. If any of you know better than me, feel free to jump in and say So why do we care about this? The big problem, well, many of you are probably familiar with the ASM library that allows you to manipulate bytecode. So if you want to make your own agent that instruments bytecode for like gathering coverage information, or finding coding problems, or doing aspect-oriented code injection or whatever, you might use ASM to manipulate the bytecode. And ASM has a couple ways of dealing with this problem. Option one, you can define these stack maps yourself. So if you modify the code, you can explicitly say, all right, here's what the types should be at this point. And that is really difficult to work with. I played with that some, had some success, but it's really awkward to work with. And another option, ASM is able to compute it itself under certain assumptions, but those assumptions are rather dubious. So the case that I was working with, we're writing an instrumentation agent. And so the way this works, the Java virtual machine calls into our code whenever it's about to load a class. And it says, hey, do you want to modify this class before I load it? And we say, okay, yeah, let me try and modify that class. The problem is, if I'm loading the code with this method in it, it's not necessarily the case that C1 and C2 have been loaded. So I can't query the type information about C1 and C2 to figure out how do I combine these two to find their common supertype to figure out the stack map information. So you have this kind of crazy dependency where you might have to consult classes that haven't been loaded yet. You can ask Java to load it while you're doing the instrumentation, but if you do that, then it bypasses your instrumentation while loading that class. So it kind of does the wrong thing quietly if you kind of go that route, which is not fun. There are a few solutions to this problem, the way I see it. One way you can deal with the problem, which is largely the approach that I took, is don't inject new control flow. So if you're just inserting new instructions that are just like straight line instructions in between existing instructions, then you're fine, because Java only needs this stack map information where you have control flow coming together, because otherwise it can just do the analysis very quickly, you know, if it's going through straight line code. It's where the code has joins that the extra information saves it time. Another thing you can do, there's some cases where you might want to, insert, you have a method call, and you say you want to insert code that always happens before that method call, and you want to insert some other code that always happens after that method call. But the problem is that method call might throw an exception. And so what you basically want to do, if you were just rewriting the source code, you'd put something before it, and then you'd put a try, and then you'd put the method call that was there, and then you'd put a finally, and then the code that you want to do always after that method finishes, even if it throws an exception. That's not very easy to do in bytecode. You can do it, and if you do it in Java 8, you have to deal with all this stack map business, and you might, because you're inserting complex control flow where there wasn't any before, at this method call, you have to deal with this stack map, and it's not fun. Hopefully, so it might be possible for someone to implement a super smart instrumentation API that sort of gathers all the available information that's already there and enables you to do kind of all the manipulations that are possible using the available data without consulting outside type hierarchy information. But I don't think anybody has implemented that yet, and it would be very difficult to get right. That's all I have. If there are questions, but I guess the one of the themes that I want to emphasize is that making the Java bytecode harder to deal with really makes it harder to adopt the platform. So there are other languages that compile the JVM bytecode, and the more difficult it is to generate and to work with the bytecode, the more the fewer people who are going to adopt the platform.
So do you have an example of that file in the new format?
I don't really. I don't. Let's see. I used Java.
What would it look like?
Well, it would still look like this, but there would be extra auxiliary information that says, oh, by the way, at point 21 on the operand stack is one element, and its type is comparator, and it would probably say the local variables are the same as at the start of the function.
Would that be similar to those comments then? Is that like those // text?
Not really.
We can get it for Java 8.
So you mentioned that Java 8 is where this is introduced. If you were using the Hibernate and or Spring transactional annotations that are using SeaJUG to rewrite the methods, is that currently supported? Does anybody know if Spring and Hibernate with the transactional annotations are working in Java 8?
Yeah, that's why ASM does the stack, well, generate stack frames if you're using, that's a big reason for using it. So that's why Groovy, had this issue, having to overcome this problem with the split frame. So yeah, basically everybody's had to rework their stuff to generate stack frames.
Does the instrumentation API not receive the existing information?
Well,
The
you
original
can.
bytes?
You could use reflection to inspect existing type hierarchies.
I thought you got the byte array.
you get the byte array of the class, but the information that you really want to help you out is information about other classes.
So if your IDE is set up to compile Java 8, can you retrograde to the previous verifier? Can you specify? So that when it actually runs in the JVM, this is backward compatible?
Well, you can ask the Java compiler to target Java 6 bytecode version, assuming you don't use any new libraries, and you could use the old bytecode format that way.
What about all the other JVM products, Scala and
Yeah.
Everybody had to go through this. It's been not a good year.
So trying to understand the problem, I don't quite understand it. So you're saying that when the JVM is executing, it when it gets to line 21, right now in the new version, you would have something that would tell it that, okay, the object is a comparator, right, somehow. It's written. So why is it that you can take that and just use that and put it, like if you have modified the code, why can't you just take that and stick it wherever you think it should be?
So, like I mentioned here, if I'm just inserting code and I'm not changing the structure of the function, then I can reuse the existing information because I haven't changed what is on the stack at these control flow join points. But if I need to do something like insert finally code, that creates extra complexity in the control flow, and I need to worry about this. I need to add more stack mount.
So you're talking about when you have a case when it's not a C1 or C2 type, you bring get another type, and that's the type you don't have good information, right?
Well, I mean, this isn't a great example. This is just showing you a method. I haven't really shown you, like, what if I want to change this method in this way.
But so long as you're changing it, but you're not bringing anything new, changing the flow control too. But so long as you're working only with C1 and C2, don't you have all the information in the file?
Not necessarily.
If one of those constructors throws an exception, then you're in trouble, even with this one.
Well, not the signature of the message. If you were to insert any code other than straight line code, you're going to have to generate stack maps. If you insert any branch, any go-to, like the try blocks, a case switch, any of those, you would have to generate stack maps for those. If you're just going to do straight line code, do, add, plus, invoke, that you can do all you want, and you keep the same stack frame. Because you're going to have to end up with a stack balance at the end of that, right? You can put things on the stack and take them off, but your straight line code is going to have to be stack neutral. And so that's why you don't need stack map. But if you have any control flow, then you're going to have to generate stack map. And that is when something gets a lot more complicated.
I think that in theory, almost any manipulation that you would want to do, you could compute the stack map information. ASM doesn't make that easy for you to do because it has this way of automatically computing all the stack map information from scratch. But it assumes that it has access to the class hierarchy information of any referenced classes. And so you can't really, what you want in the instrumentation case is to say, all right, leave the existing information there and use that to fill in any gaps that I've created by instrumenting the code. That's what we really want to happen. But and I think that in theory there could be a way to have an API that supports that. But as far as I know, nobody's written that because it's a complicated thing to do. And so ASM kind of forces you to do, either you specify it all yourself or we recompute it all for you.
General question, so what the contract is with the verifier, like what happens if you get this wrong? So you write in something which is not actually true, but the verifier is looking at what you put in the bytecode. What occurs, I mean, what is it the verifier is actually verifying? Like if you manage to write the wrong stuff, are you able to execute invalid instructions through the JVM? Does it not?
So it will, the typical case is that it will throw a verify error. Unless you pass a different JVM argument, it will throw a verify error saying there was something wrong with your bytecode. Whenever the class ends up getting loaded, it'll throw a verify error.
What's causing that? So tell me, I mean, is that because it's checking at runtime the actual type against what you put in this metadata and those don't match? That's the check it's going to do?
Well, it checks at class load time so it's going to, the information that's recorded right here,
Right.
it's going to use that to kind of check, do kind of a proof check. And if it was given invalid information, that proof check is going to fail because some steps in that proof check were not valid.
How did it know? I'm confused on what it's verifying. Like if it knows the truth, why do you need to tell it? I mean, what are you telling it?
Because it might take up to n squared time for it to figure out what the truth is from just this information. But
it knows immediately that it's wrong.
This is the proof
No.
carrying code stuff, right? I can check whether what you're telling me is false, but I can't. But if
But I
I
can't
have to
find out
come
what
up with
the
the
truth
answer myself, it takes me a longer time.
Is
Yeah.
that right? Okay.
And
Okay.
space.
So that's it's sufficient to tell it's wrong, but I can't tell what it's meant to be. Okay, I buy it.
Because the join point is gonna wanna know that you have this lowest common ancestor, right? But now you're gonna promise this is what it is, and it's gonna say, yes, that's actually there. You can't lie to it in that sense.
But you can pass the no verify option to the Java virtual machine and then kind of, all bets are off or something like that.
Isn't that the J2ME stuff, wasn't it? Didn't it do that? You did the verification before you.
Yeah,
like
this
a
stuff
Java
comes
instance
from
that
J2ME.
You did it earlier, and then
Yeah,
you
some
sent
of us
it
had to deal with this
firm
years
that's already meant to be verified, right? 'Cause I'm sure this is for mobile stuff too, right? That's what they care. Android or whatever, it's like not running fast enough.
All right, cool. So I guess with that, there's no more questions. Thank you for coming. Thank you to all the speakers. Again, we won't meet in December or January, so we'll see you folks in February. Gonna go for beers. Please stick around, and we'll go down the street. Thank you. Good night.